I was discussing about some particular considerations regarding endogenous variable and instrument variable. Up to this level, you have understood what is endogenous variable. Endogenous variable is a variable which is significantly correlated with the error term. So in that case, we need to provide some instrument variable, which should be a replacement of that endogenous variable, and it should be the relevant variable. You cannot use a variable which is not related with your endogenous variable. But always remember that an instrument variable is considered an instrument variable or relevant instrument variable when it is not related or which is not correlated with the error term. So this is the basic consideration that you need to understand. For example, we you have heard about the firm's size. It may be measured by log of total assets, and it may also be measured by log of total sales, and it may also be measured by log of number of employees. So there are three basically the measures that you can use to consider the firm size, and it can also be measured by the market capitalization of the firm. There are four measures. For example, if you are using the first one in your dynamic panel data model, and after some analysis, we came to know that uh, log of total asset as a measure of firm size, it becomes endogenous. After the initial analysis, you came to know that log of total asset become endogenous in your model. Now, as a replacement, what variable we can use? We can use log of sale, log of number of employees, or market capitalization as a replacement of this endogenous variable in our model. So at first, we need to check whether log of total sale, whether it is correlated with error term or not. So if it is not correlated with the error term, it will become the instrument variable, which would replace the firm size of log of total asset. But if it is also correlated with the error term, it would become the endogenous variable, and you cannot use this one as a replacement or as an instrument variable. In that case, you need to consider the third one. For example, it is not correlated with the error term, then it will become the instrument variable. Instrument variable. And let's suppose this is also correlated with the error term, then you cannot consider this one. Then you go to the market capitalization of this one. And in that case, for example, all of these are endogenous. For example, endogenous. Someone asked me if we have some set of variable according to literature review, and all of them would be correlated with the error term, then what to do? Always remember, if given set of possible choices are also correlated with the error term, you cannot use them as a instrument variable. In that case, you can use the lag value of your endogenous variable as a instrument variable. You can check whether the first lag of total assets, log of total assets, first lag of log of total assets is uh, significantly correlated with error term or not. And in that case, you can consider it as a instrument variable. So these are the basic consideration that you need to understand with the endogenous variable and with the instrument variable. So, what is the next thing that you need to understand? Because these are the basic terms that you need to understand. So, I have discussed that the current value of DV is significantly correlated with its past value. Independent variable is significantly correlated with error term, which is endogeneity. In that case, we need to find an instrument variable which is alternative to your endogenous variable and which is not significantly correlated with the error. So up till this level, you have understood these things. I am trying to summarize the basic consideration in a more simple way for your understanding. The next thing is the decision to use either the static panel or dynamic panel is depends upon the serial correlation and autocorrelation test. These are some assumptions. If you really want to use the static panel or dynamic panel, you need to test whether your model has serial correlation or autocorrelation or not. So if if your panel data model, if your panel data model has serial correlation and or autocorrelation, both are the same things. You can consider it as a serial correlation or autocorrelation, along with along with group-wise heteroscedasticity issue. Then you are free to go with dynamic panel data model. So this is another assumption that you need to check uh, before applying the dynamic panel data model. So what we have concluded so far, we have concluded that we should have a small t, we should have a large n, we should have a lag dependent variable as a independent variable, and we should have a endogeneity issue that we can check using the strata. I will let you know tomorrow how to check endogeneity, and how to find out the instrument variable. So after you have finalized the instrument variable, you need to check the serial correlation, autocorrelation, and group-wise heteroscedasticity. So if these problems are there, you are free to use the dynamic panel data modeling and estimation methods. Estimation method. So this is the basic assumption. So these are the summary points that you need to understand. First, you need to find out whether your panel data model has serial correlation and heteroscedasticity or not. If serial correlation found, then secondly, you need to identify whether your panel data model has endogeneity issues that I have already discussed. If endogeneity issue is confirmed, then you need to identify which independent variable is endogenous. So there are certain ways where you can find out the endogeneity and where you can find out which variable is endogenous variable. So I will let you know how to identify endogeneity and how to identify the endogenous variable. So after identifying the endogenous variable, you need to find an instrument variable which you can use to replace the endogenous variable. This instrument variable should not be correlated with error term. So if you could not find an instrument variable to replace the endogenous, you can use the first or second lag of your endogenous variable as an instrument. So I will let you know how to do it. So note the instrument should not be correlated with error. So always remember that your instrument would be considered an instrument variable if it is not correlated with the error. Now you can use the GMM estimation like difference GMM and system GMM. These are the two method of estimation under GMM technique, which is basically used with dynamic panel data modeling. So if the panel data is strongly balanced, it means that all of your countries or all of your companies would provide the data for all of the years or same number of years for each company or each country. Then it is known as strongly balanced. So for example, if you have for example, uh, 10 for example, if you have 30 companies and you are using 10-year data, 10-year data, it means that each of these countries might have 10-year data. So all of the companies would have 10 years of the data. None of the countries would be 9-year or 8-year or 7-year of data. All of the companies might have same number of the years data. In that case, it is considered as a strongly balanced. So if your panel data is strongly balanced, in that case, you are going to use the difference GML. But if your panel data is unbalanced, it means that some of these companies might have 10 years data, some of these companies might have 9-year data, some of these companies might have 5-year or 6-year data, then this data is considered as a unbalanced. In that case, you are going to use system GML. So that is the basic difference that you need to understand. If your data set is balanced, strongly balanced, you are going to use difference GMM. But if your panel data is unbalanced, then you are going to use the system GMM. So this is the basic consideration that you need to understand here. All right. This is how you can consider if your data is strongly balanced, you are going to use difference GMM as well as system GMM. But if your data is unbalanced, you can only use the system GMM. So any independent variable which is strongly correlated with error term is known as endogenous variable. I have discussed with you. So any independent variable which is the replacement of endogenous variable is not significantly correlated with error term is known as instrument variable. I have also discussed this. These are the commands, but I will let you know after some point in time about it. So let me conclude some of the summary points that I have discussed. I was discussing here this paper. Dynamic panel data models are divided into two types. Now, this is very important thing that you need to understand. When you are considering the dynamic panel data model, it is divided into two types according to Green 2003 and Tagolo 2013. It is known as autoregressive panel data model and distributed lag panel data model. So I need to write here two types of dynamic panel data model. Let me write here. There are there are two types of dynamic panel data models. The first one is known as, if we see here, autoregressive panel data model. Autoregressive panel data models. And the second one is known as distributed lag panel data model. Distributed lag panel data model. So what is the difference between both of these types? So you need to understand that uh, the auto-regressive panel data model is a model in which the lag value of the dependent variable are included as a independent variable. So when the model contains only the, the lag dv as the IV, all right? So this is the basic consideration. Autoregressive panel data model have only the lag dependent variable as the independent variable. Like in our case, this is basically the autoregressive panel data model because it has the lag dependent variable as the independent variable in the model. While in case of distributed lag panel data model, what is it? What it is? It says that in which the lag value of independent variable are included as an independent variable. So sometimes we may use the lag independent variable. So let me write here when the model contains the lag IVs as the IV of the model. It is known as distributed lag model. For example, if I would copy here it for your consideration, let me show you like this. This is basically autoregressive panel data model. So what would be the distributed lag panel data model? Sometimes your dependent variable, the lag value of your dependent variable may not be influencing independent variable, or sometimes along with this condition, there are some independent variable, the lag value of which would be considered as a additional independent variable. For example, let me write here beta 3 as a x3, which is, or sorry, x2, which is basically it minus 1, it minus 1. So if you see here, this is the lag independent variable as a additional independent variable in this model. So we have x2 here and we have x2 it minus 1 here, which is the lag of the previous independent variable. So in that case, it is considered as a distributed lag panel data model. So these are the two types. So what does it says about these two types? It says that Arlino and Bond, these are basically the developer of GMM estimation method, Arlino and Bond, 1991. Arlino and Bond, 1991, developed the difference GMM method of dynamic panel data estimation. So I have discussed with you the history of GMM estimation method. I have discussed with you that in Stata, the difference GMM method was introduced in 2001. But this difference GMM estimation method was developed by Arlino. Let me confirm from here. This is Arlino and Bond, 1991. Arlino and Bond, 1991. Like here, I would need to put here. So manually, this procedure was introduced by Arlino and Bond, 1991, and it was uh, It was introduced in Stata in 2001. While in order to solve the problem in auto-regressive model, so always remember that if you have the model like auto-regressive, the first one, auto-regressive panel data model, you are going to use the difference GMM, which was introduced by Arlino and Bond. So if you have a model like this, so you need to confirm two more conditions with these things. Always remember that in order to use the difference GMM, you need to have a balanced panel, a strongly balanced panel. The second thing is if your balance panel is confirmed, then you are going to use difference GMM for estimating your autoregressive panel data model. So these are the basic consideration. You have a strongly balanced panel, and you are going to use the difference GMM. It means if you have the model, this model, which is distributed lag panel data model, and you may have strongly balanced or sorry, you may have strongly balanced or unbalanced data. You can use the system PMM method. So these are some basic considerations that you can apply here. Since the lag value of independent variable are used as an instrument variable by taking the first difference of the variable in the development of this method, it is called the difference VMM that we have discussed. However, in case of unbalanced panel data or when T is small, there is a data loss in the first difference transformation. So if you have unbalanced panel data, you are not going to use the difference VMM. If you have strongly balanced panel data, you are going to use the difference UMM because in case of unbalanced panel data, there is a data loss in the first difference transformation because in case of difference UMM, you need to apply the first difference transformation. So always remember this. For example, if there is no data for YIT, the data for change YIT and change YIT minus 1 will be lost in the first difference transformation. Because of these problems, Arleno and Bauer 1995's difference GMM, an effective instrument variable estimator, was developed using orthogonal deviation method. So they have introduced this method, difference GMM, using orthogonal deviation method. This is the further development into difference GMM technique that they have applied. With this method, the difference between the current period and the previous period is not counted. Instead, the average of the future value variable is used. So this is known as orthogonal deviation method in difference GMM. So what they have further discussed, in this way, the data loss caused by difference GMM, especially in data set which are especially unbalanced, is minimized. Now, this is very important thing. This method, which establishes equality between an original system and transformed system and estimate them as a one system together, is known as system GMM. This is the definition of system GMM. System GMM is based on combining the difference equation and the level equation, and it has been proven that it is proportionally higher estimation ability than the GMM. So system GMM is much better technique because it is most efficient than difference GMM. So the estimation method of Arlino-Bower blended bond, one of the system GMM method, two-step GMM estimator for estimation in our equation is used. Considering that the panel data set is unbalanced and T is low, with algorithm developed by Rodman 2006. Now, this is basically the further development in the GMM method. So, what we have concluded today, we have concluded a lot of things today, like we have discussed what is dynamic panel data model, and we have discussed the two types of dynamic panel data model and two estimation method like difference GMM and system GMM and how they look like in econometric modeling. What are the basic considerations that we need to understand? We have also discussed that in case of dynamic panel data modeling, we cannot use the pooled OLS, fixed effect, random effect panel, ARDL, etc., because they would give us biased estimate. We have also discussed that GMM estimation like difference GMM or system GMM would be used. Different GMM was introduced in Stata in 2001, while it was manually developed by Arlino and Bond in 1991, while the system GMM was introduced in Stata in 2005 and upgraded in the later years. While we have also considered what is endogeneity and how it is defined, we have also discussed the instrument variable. We have discussed that instrument variable is basically used as a replacement of the original variable, and it should not be significantly correlated with your error. So these are some of the basic considerations that we have discussed. Tomorrow, we will deeply analyze some of the further detail with it, and we will discuss the Stata procedure for dynamic panel data model. So do you have any question, Mohammed Wakar, regarding to this discussion? All right, Wakar said that there is no issue, there is no question here. So let's conclude today's session. We will discuss the further consideration in dynamic panel data modeling tomorrow, and we will also discuss the procedure with Stata. If possible, send me this file. All right, I will share this file, but let me complete this file tomorrow because there are some other things that I would like to include in this file. So I will share the updated version of this file with you tomorrow. So stay blessed. Thank you very much for joining, and let's meet tomorrow with the same time at the same topic. Thank you very much, Napar, and thank you everyone for watching my YouTube videos.